All right, here we are, Kinesiology 230, Chapter 7, still talking nutrition concepts and strategies. This is presentation 3 out of 3. Just going to talk about micronutrients, and talk a little bit about hydration. The book goes into supplementation and a few other odds and ends, but I'm going to leave those out of this presentation. You can read through those at your leisure. Let's just talk a little bit about macronutrients. Those are the main ones: protein, carbohydrates, and fats. Protein, 4 calories per gram. Carbohydrates, 4 calories per gram. Fats, which is represented over here, 9 calories per gram. So I talked earlier about nutritional density versus caloric density in another presentation. So if you look at these, you can see fat is calorically dense, whereas it might not have the same nutritional density as some of the other foodstuffs that are seen here. With protein, it's used to help, repair and build tissue. We talked about how it's broken down into branched chain amino acids. It helps us rebuild muscle tissue after a workout. It can be oxidized for energy through the BCAA process. As an interesting sidebar, the book notes as caloric intake goes down or glycogen levels are low, protein requirements increase, which I thought was kind of an interesting sidebar in the book. I had not read that before, but it makes sense in terms of a percent of diet. Now, the RDA for protein is 0.8 grams per kilogram of body weight per day, but athletes will probably fall in place more like 1.4 to 2.0 grams per kilogram per day, give or take. And you can do the math on that in terms of just how much protein you would need for your own situation. In terms of like proteins, like the main ones that they list in the book that are reference proteins: meat, fish, poultry, dairy, eggs. Oftentimes you'll see eggs, like one egg equates to, or one steak will equate to how many eggs, et cetera, in terms of the perfect protein. I would just look at this and say, okay, remember that the reference proteins the book provides are meat, fish, poultry, dairy, eggs. So when we talk protein, when we talk about these requirements, in the most part, they note here that concerns about protein negative effects of high protein intakes are unfounded, especially in healthy individuals. So you can consume larger amounts of protein and not have to worry about it. But now, if you're talking excessive, like maybe 4 grams per kilogram, it might be a little bit much. But the concept of excessive protein and how it's processed in the body and how it's challenging for the kidneys, and you have to actually excrete out all the nitrogen. I get that. I understand the follow through on that, but the book does not really reference that per se. So I wouldn't stress too much about that in the context of our class. The other thing that they point out is if you end up eating extra protein, it is or will be extra calories, and those can end up being stored as adipose tissue. Now, with carbohydrates, carbohydrates are the primary fuel, and typically the typical recommendation is like 60 to 7% of a diet should be from carbohydrates. And CHO, C6H12O6, that's just some abbreviation for that. Activity matters in carbohydrate intake in terms of if a person is a distance runner or not, or what their activities are. Ketosis, are high levels of ketones in the bloodstream, and that results from an incomplete breakdown of fatty acids. So you end up having this process where you go ketogenic, or go to a ketogenic diet format, and that plays on a very low carbohydrate diet that causes ketosis. I put these 3 in here. You can look these up at your leisure: Atkins, keto, and paleo. Those are very low carbohydrate diets. Perhaps you'll find one that'll work for you. And you can also reference out to this Wikipedia article regarding low carbohydrate diets. With fats, the body has a low requirement for dietary fats. You don't really need to eat a lot of dietary fats, but what we find is about 34 to 35% of the calories in the typical American diet are from fat. You'd like to have 3% from omega-6 linoleic, and then 0.5 to 1% from omega-3, which is alpha linoleic. If you would like, you can go ahead and link out here if you want to learn more about the difference between linoleic acid versus alpha linoleic acid. But the RDA for fat is roughly about 20 to 35% of daily calories, and you want less than 10% from saturated fat and less than 1% from trans fat, which you'll find, I believe, in a test question somewhere else, but what you'll find is that most people will rationalize that 34% of their calories fit right in line with daily calories, and I would contest that you could probably eat a little bit less than 34% calories from fat. The book puts us up here. This is table 7.4. This is for your reference. In terms of some of the requirements, notice you have male versus female, tolerable limit. You might have some people who are on some type of vitamin protocol, where they'll have like a high amount of units, if you will, or a high amount of milligrams per day, whatever their actual amount is that they're taking. But what I want to point out to you is this is for individuals 19 to 30 years old. So you might have people who are younger or older, and they'll also have different requirements. With dietary reference intakes, the DRIs are split into four main categories. These are recommended daily allowances, RDA. It meets the nutritional needs for almost 97 to 98% of healthy individuals within specific groups. Adequate intake is the goal intake when sufficient scientific information is unavailable to estimate the RDA. Estimated average requirement is the intake that meets the estimated nutrient needs of half the individuals for a specific group, and tolerable upper limit intake level is the maximum intake that is likely to pose risks of adverse health effects in almost all healthy individuals in a particular group. But as I mentioned, you may have individuals who might have, because their doctor has recommended it, they might be taking like very high doses or amounts of particular vitamins as for medicinal purposes, and it might take them above this tolerable upper intake level. But in general, what we'll talk about with most of our clients is recommended daily allowance, because it just fits with 97, 98% of the people we talk with. So hydration, it varies based upon the activity, and the environment. The key that you'd like to have is you want to hydrate early and hydrate often. If you're trying to hydrate when you're going to play a sporting event at 8 o'clock in the morning, you're trying to drink a bunch of water at 7:30, you've missed the boat. You have to hydrate at 7 o'clock the night before and start the hydration process the day before to be fully hydrated. And then when you're competing, then it's sipping throughout the event to make sure you stay hydrated. So the other key is, if you're thirsty, it's too late. You're already dehydrated. The thirst response itself is triggered at about 1% dehydration, and you want to make sure you're not triggering that thirst response when you're in a competitive event. Now, sweat loss, we can measure just how much water weight you lose if we weigh you before a competitive environment or a workout, and then we weigh you after a workout. So if we look at this and we go, okay, hydration is usually broken into these categories: before, during, and after exercise. So before exercise, you want 5 to 7 milliliters of fluid per kilogram of body weight at least 4 hours prior to exercise. I would highly recommend memorizing that. During exercise, as you're sweating, you can have 1.8 liters per hour lost, depending upon the environmental considerations. So you're looking at replacing or replenishing 1.8 liters per hour. You can do the math on that in terms of how many glasses of water you need to drink to keep up with that sweat loss. Then after exercise, you need to drink 20 to 24 ounces of fluid for every pound lost. Now, what I don't like about the way the book does things is they put this in the book and they put it in at 5 to 7 milliliters, 1.8 liters, and then they go into ounces, which I just think is silly. You got to stay consistent, but just realize these are the numbers that they're providing. It's milliliters, 5 to 7, 1.8 liters, and then 20 to 24 ounces of fluid for every pound thereafter. Now, if you drink too much water, or you have a very long or prolonged workout event, very long endurance activity, you'll end up with hyponatremia. And this is a test question on the NSCA exam. Hyponatremia, if you, for example, go into the main physical fitness or physical education building on campus, We have a swimming pool. Where a swimming pool is housed is called the natatorium. Natatorium in terms of it's a pool full of water. Natatorium. Hyponatremia, you're talking about hypo, increased nat water, like a emia, right? It's an effect, a negative effect. The long story short, what happens with hyponatremia is this. You have a long duration activity, you drink lots of water, you don't replace sodium, and you end up having this drop in sodium levels in the blood, and that causes a deleterious effect in terms of the ability to contract muscle effectively. So you've got to make sure if you're doing long-term duration activities, you have to replace sodium. They talk about weight gain and weight loss in the book. On the weight gain side, 1 pound of muscle contains about 500 to 600 kilocalories. Muscle gain requires an intake of at least 1.6 grams of 1.6 grams of protein body weight per day. And then, the calories should come from high quality protein sources, and you're looking for positive energy balance. On the weight loss side, average loss of 1 to 2 pounds per week represents a daily caloric deficit of 500 to 1,000 calories per day. And that can come from cutting diet 250 and then working out and burning 250, or just cutting 500 calories in your diet. But the math comes from the fact that a pound of fat is 3,500 calories, and 3,500 divided by 7 is what gives us the 1 to 2 pounds over a week. If you take out 500 per day, it's going to give us our numbers. So just think of it mathematically, right? You have 7 times 5 is 35. If you take out 500 calories times 7 days, that's going to give us our 3,500 calories. That's going to be a pound of fat. There you go. Thought you never had to use math again. So the rate of loss between half a percent and 1% of total body weight per week is recommended in the book. I can tell you that will be kind of specific to the person. Bigger body people who need to lose a lot of weight will lose on order of multiple pounds in a week, whereas people who don't need to lose a lot of weight will lose smaller incremental amounts. So it's based off a percentage. And you're talking about a negative energy balance when you're talking weight loss. All right, so for each of the above, you got to give consideration to the caloric and nutritional density of food, as I mentioned earlier. In general, you may have to guide athletes towards foods that are high in nutritional density but low in caloric density. Usually people are very much into a calorically dense diet with low nutritional value, and you just have to guide people out of that cycle. So with that, guys, I'm signing off and moving on to the next chapter.